Today I'm going to be teaching you the mathematical properties. Those properties would be commutative property, identity property, and associative property. The cool thing about properties is that any property that works with whole numbers also works with integers, with rational numbers. Let's start with commutative property. All right, let's think about the word commute, the root word of commutative. What does it mean to commute? Well, when I drive into Lynchburg and come to LCA every day, I come from Concord. There are some teachers who come from Forest. I've known teachers in the past to drive all the way from Roanoke and other surrounding counties to come to LCA. Well, we're commuting here. We're all driving here from different locations, different areas, and once we get here, we have the same destination, but we started in different places. So, commutative property is the same kind of an idea. Numbers are moving in commutative property. They're switching places. So let's look at commutative property of addition. Commutative property of addition just says that the numbers are changing order. There's a changing order of add-ins, and it doesn't change the sum. So when you move those numbers around, the answer, the sum, is not going to change. 6 plus 2 is equal to 2 plus 6. Doesn't matter the order. This is 8, and this is 8. 9 plus A plus 4 is equal to 9 plus 4 plus A. It doesn't matter the order, but we're going to come out with the same answer. 13 plus A. Now, if you see here, we moved the 4 next to the 9 to make it easier to add those two numbers together. And that's what commutative property does. It helps you out. It lets you move together those numbers that make sense to go ahead and add first. So we get 13 plus A. For multiplication, you can do the exact same thing. You can change the order of the factors, and it does not change the product. It will not change your answer. 7 times 8 and 8 times 7 are both 56. Doesn't matter the order of the two numbers. 3 times G times 4 is the same as 3 times 4, which is 12. A lot easier to go ahead and multiply that rather than 3 times G and then that times 4. We get 12, and 12 times G is 12G. So with subtraction, you cannot commute. Commutative property does not work because 6 minus 2 would be 4. 2 minus 6 would be negative 4, and those are opposites, two totally different numbers. So in division, you can't use commutative property with division either. So with the inverse operations of addition and multiplication, commutative property does not work. Okay, let's talk about associative property. Now, associate. What does that mean? What's the root of associative property? Associate means who do you hang out with? Who do you talk to? Who do people connect you with? Those are the people that you associate yourself with. Well, associative property has a lot to do with that. How you group numbers, how you put them together. So, addition and multiplication problems allow you to change the groupings. All right, let's take a look at some examples here of what I'm talking about. 8 plus 5 plus 20. Here's the grouping right here. Okay, these are like friends, 5 and 20. 5 and 20 and 8 are all friends. Maybe in my story here, 20 invited 5 and 8 over to her house to watch a movie on the television. Plus sign kind of looks like a T. And 5's mom said yes, that was okay. 8's mom said no, you'll have to watch that movie at home. And so 8's at home watching the television while 5 and 20 are in the den, which is where the parentheses are. They are at 20's house watching the movie. And so they have a grouping. They're associating themselves together. Well, this is the same as 8 plus 5 associating themselves together, in this case, plus 20. So the grouping now is 8 plus 5. And then we have the 20 on the outside. But it doesn't matter. In both cases, I'm still going to get 8 plus 5 is 13, and 13 plus 20 is 33. In this case, I'd get 25, and 25 plus 8 is also 33. So the answer is the same, no matter what grouping I add first. My answer is going to come out to be the same thing. But sometimes making these groupings makes it easier for you to add. Maybe two numbers are simpler in your head to add than another group of two numbers. Let's look at this one. 16 plus 2 plus f in parentheses. Well, 2 plus f, can't put those together. So let me make a different grouping. Let me group 16 plus 2. That gives me, plus f, that gives me 18 plus f. And this is where I have to leave it because I can't add a variable to a whole number since I don't know what this variable represents. So next we have 9 times 10 times 3 in parentheses. Well, maybe it'd be easier for me to multiply 10 times the 9 first. So I went ahead and did that. I grouped 9 times 10 together, which gives me 90, and times 3. I know 9 times 3 is 27, so 90 times 3 must be 270. Let's look at the next one. I have 3 times 2f, which equals 3 times 2, and then I made my grouping with 3 times 2, and then I have f outside of parentheses, which does mean multiplication. And 3 times 2 is 6. 6 times f is just 6f, since I do not know what f represents. We can't go any further with that. So associative property is just creating groupings that help you to add and multiply. Identity property. Identity property is simple. It just says that with addition, when you add 0 to any number, you just get that other number. Here we have 3 plus f plus 0. And that's just simply going to be 3 plus f because when you add anything to 0, you're just going to get that other number. So there's also the identity property of multiplication that says any number times 1 is just going to give you that other number. For example, 1 times n is just n. G plus 4 times 1 is just g plus 4, or 4 plus g. Okay, let's evaluate some numerical expressions. Let's take 34 plus 47 plus 16. And let's look at a way that we could use a property to help us better solve this. I'm looking at it and thinking 34 plus 47, right off the top of my head, I can't add that quickly, but 34 plus 16, I can put the 6 and the 4 together, and that gives me another 10. And then 30 and 10 gives me 40. So together, these two numbers, the 34 plus 16, give me 50. And then I'm going to add the 47 to that, which easily I can see is 97. Here I have 5 times 13 times 2. So I'm going to look to see what property I could use in this scenario to help me to solve this quickly. Well, 5 times 13 right off the top of my head, quickly, maybe I can't think of what that would be, but maybe if I put the 5 and the 2 together first, and then multiplied by the 13, 5 times 2 is 10. And 10 times 13, I know I'm just going to add a 0 to the end of 13, which is 130. Okay? In both cases, we use commutative property, and we just simply move the numbers and switch the order to add and multiply these. Let's look over here at an algebraic expression and simplify it. Here, we have 3 plus 4 plus c. So I am simply going to put 3 plus 4 together and say 7. And 7 plus c is just 7 plus c. All right, here I have 9z times 0. And 9z times 0 is just 0. And here I have 4 times g times 9. And I'm just going to switch the order here, use commutative property, and say 4 times 9 times g. Because 4 times 9, I know, is 36. And 36 times g is just 36g. And here I have 3 times z times 1. And I know that if I say 3 times 1 times z, 3 times 1 is identity property. That's just 3z. Okay, here's some ways that might help you visually to remember what these properties mean. Here's commutative property. And the C and the O at the beginning of commutative property can help you to remember that in commutative property, we change the order of the numbers. Associative property is a grouping. And sometimes we switch the groupings to help us to better to add or to multiply. But we can remember just simply by putting parentheses inside of the word that associative property is a grouping. All right, last we have identity property. Identity property, we have a number 1 that goes with multiplication, because every time we use this multiplication symbol and multiply by 1, we're just going to get that other number. Also, we have 0 here and a plus sign, because anytime we add a number to 0, we're just going to get that other number. And that's the identity property. It's like looking into a circle-shaped mirror and you just see yourself, and that's what the numbers do. When you add 0 to any number or variable, you're just going to see that number or variable. Same with multiplication, except this time you're looking into a one-shaped mirror, a rectangular mirror. And you're just going to see that number's reflection, or just going to see that variable's reflection. Okay, on this slide, I want you to push pause, and I want you to name the properties and fill in the blank up here, and I want you to simplify the expression and name the property down below. Okay, so let's go ahead and take a look at this one. 325 plus blank equals 975 plus 325. Well, this is just simply commutative property. I've just switched the orders because these two numbers are the same. So I know that this is going to be 975. Okay, let's take a look at this one. 17 times 5 times 2 outside of the parentheses equals 17 times, and in parentheses, 5 times 2. And the numbers did not switch order. Realize that the numbers are in the exact same order that they were in this case. The only thing that changed is that the parentheses moved. The grouping changed. All right, simplify the expression and name the property. 9 plus 2 plus c. Well, we're going to change the grouping here. And again, this is associative property. Excuse me. Because I'm going to change the grouping from being around 2 and c to around 9 and 2. And that's going to give me 11 plus c. And that's as far as I can simplify this, because c is a variable and I don't know what it stands for. So now I have 13 times f times 5. Now I'm going to switch my numbers around, and this is going to be commutative property, because switching my numbers around is going to help me better multiply these numbers. So I'm going to say 13 times 5 times f. I know 13 times 5 is 65, and then times f is just 65f. All right, last I have 16z times 1. And this is simply identity property of multiplication, because I'm just multiplying by 1, and this is going to look in that one-shaped mirror and see its own identity. So 16z.